Okay, so today we're going to talk about what time series is in regards to monitoring and using it to gather data for real-time analytics with the various applications that you guys are building. So today I want to make sure that we get a good understanding of what the definition of time series is, and what the differences are between the various time series databases that are out there. And we'll quickly go into the InfluxDB model. But I want to spend a good portion of time also reviewing a couple of really interesting use cases with everybody on the call today to serve as inspiration for how you might use a time series database in your applications. So very quickly, what is time series data? And very simply, it's basically time-stamped data. So it's a timestamp with some kind of a value, right? It's going to be 6 o'clock in the morning, with a value of maybe the temperature at that time. And when you collect a sequence of that kind of data and you actually graph it out, you'll be able to see that one axis will always be time. And really, you use this kind of information to be able to track performance, right? You want to see, or you want to track differences. So you want to see what the temperature was a minute ago compared to right now. Or you want to understand the pressure, the water pressure of a pump from 30 seconds ago to now, or you want to understand server utilization or storage, etc. So there's a number of things that we all want to just be able to track and understand, and we may want to do that to predict that something's going to go wrong. So I might have to do some kind of maintenance. You may also want to do that so that you can make sure that the number of users that are on your website are what you expect. And if it's down or up, then you might make some kind of a change. It might lead to either looking at a potential problem or seeing if you can actually increase it by doing some other things. So we'll just review a couple of cases about time series data. And I only do this review just so that we can make sure that we can then, after we understand what time series data is, we can understand how it actually fits in a time series database and what are some things that we can do to augment it to make it really useful for you and your apps. So here's an example of a hashtag. What's funny about this example, you can see on the bottom, it's actually a pretty old example from 2013, but it seems really relevant because if I were to look up the number of tweets per hour that are using the hashtag royal baby, it's still pertinent. It's probably even higher than this on an hourly basis. But what this is doing is this is tracking the number of tweets per hour over time. So this is, of course, time series data. Now, in this particular instance, this graph is actually trying to show relationships based on likes and activities. And because it's not showing the relationships over time, this is not time series data. So it is showing relationships between these various things and people, but it's not telling us when these relationships were formed. This is a perfect example of time series data because all these little charts are showing some kind of measurement over time. So we have temperature, barometer readings, etc., all over an axis of time. So this particular graph is actually showing a relationship between the grades of these individuals and the category that they are placed in, probably something that you would see in high school. But it's not showing us over time if the grades got better or worse because they decided to identify with one of these different classes. So this is not time series data. And this is probably, if you're actually monitoring your infrastructure, is going to be a very typical use case of time series data. So just looking at your infrastructure to understand what's being utilized, what has a lot of load, and then starting to make some sense out of this information, trying to determine, oh, is this just a normal pattern? This is just normal behavior, things moving up to the right or down, and do I need to do something about it? In this next example, we're seeing tweets by population over a number of different countries, and it's not showing us the increase and decrease of this information over time, so this is not time series data. Another example where the relationship is actually between temperature and money, and not letting us know when the increase or decrease happened over time. So this is not time series data. So this particular GIF that we're looking at is actually showing us the popularity of a particular song from Ed Sheeran. And it is showing us over time. And it was a bit of a trick in that, of course, it doesn't have your typical graph. We don't typically, in this particular case, we don't see an axis of time. But really, this is time series data. This was just a little bit of a trick because it is showing popularity over the course of several days. And then finally, another very simple but clear example of what time series data is, just showing you the CPU load over time. Oh, I thought that was the last one, but one more just to make the point. You can see here, it's telling us that students' grades are increasing because the number of hours or number of time spent studying is increasing, but it doesn't actually show us a time interval. So this is not time series data, even though we actually do have an axis of time, but it's not showing us the measurement of time. So we don't really understand, you know, did they increase it over a specific time interval? So one thing that we like to talk about at InfluxDB, and actually there's a number of blogs that talk about this, they just might call it something a little bit different, is the idea of a regular and an irregular time series. And so we actually call regular time series metrics and irregular time series as events. And the difference is with regular time series, these are measurements that are taken at a at the same time interval over a period of time. So at every minute, I am taking a temperature reading. And then what I'm doing is just trying to understand, did that go up or down, and try to then determine if I have to do something. Whereas irregular or events are basically things that happen that might not happen on that regular time interval, on a set time interval. And both are really useful, and both are going to tell you different things. And we think it's just important to understand the differences because as you're starting to dig into doing analysis on these types of data, you want to be careful to make sure that these are indeed anomalies, or these are things that are indicators of something good or bad happening. And sometimes you don't see these things as clearly. So sometimes with events, maybe you can't really make sense of, you know, what that's actually telling us. So you might have to zoom in on the time interval, might have to go in with a higher level of precision. Or the other thing that might sometimes be useful is taking an average of these events to see if there's a pattern from that perspective. So once again, regular time series, we call them metrics, and these are just measurements that are gathered at some regular time interval. And then irregular time series are measurements that are gathered at irregular time intervals. We often call them events. And I was just talking about this just in the previous slide, that the cool thing is the summarization of these events can actually turn into regular time intervals, which may actually help you to understand a trend that might be happening with your data. And so summarizing the average response time for requests, maybe in an application over a 1 minute time interval, might actually be a better way to look at the data to make sense of, oh, is this going up or down, or do I need to make some kind of correction? So what is a time series database? Now, of course, we get this question all the time, every time I meet with any of you guys at meetups and events, etc. And basically, you know, you can store this kind of time series database in any kind of a database if you wanted to. But time series databases have a unique characteristic in that they're already optimized for time. So they already can handle timestamp data. These things are already indexed. So that you can do searches on them very quickly, and you don't actually have to do anything to make that happen. And it also can handle some of the characteristics of time series data, which is, of course, everything's timestamped. It could come in regular or irregular time intervals. But typically, if you just think about timestamp data, it's going to be a lot of data, right? We're taking measurements, and even if we take it just within a 24-hour period of time, if we set the time interval to 1 second, that can very quickly be a lot of data, because we're typically not just taking one measurement, we're taking a number of different measurements. And at the same time, the reason that we take those measurements is that we want to be able to look at them as close to real time as possible, so that if something is not right, we can then look at the data, try to determine the cause, and make some adjustments in our app or our workflow or solutions, etc. So with that, there is a sense of time sensitivity to this data as well. So time series databases, consider those characteristics and make sure that they have built features that can handle these things. So it's optimized for making sure that it can collect time, it can handle high writes, it can handle high reads. And also, they often do some kind of compaction as well to make sure that it doesn't take all the storage away from you. In addition to that, you can also do some other things, like you can basically evict that data. You can either set various retention policies for the different kinds of data that you're setting, you downsample the data, etc. Because what's interesting about this data is that in the short term, having that precision is really important, and it's going to tell you what's potentially happening with your solution. But having all that precise data over time might not be as important to you. Maybe you just want to keep the shape of the activities that you saw with that data, and that's why you might want to be able to downsample and do a roll-up of this information. So as I mentioned, you can use any database really to do this, but it's really focused on those characteristics. And if you think about it, there are various databases types that are out there. There's document databases, search, and also just your traditional relational databases that can handle these things. But those are often either more generic solutions or probably solutions that are more that are optimal for other use cases. And so that's why we want to make sure that we understand that it's important, in our opinion, that you really look at what you're trying to do and really utilize a purpose-built set of tools to make sure that it fits with what you're doing. So this is just a small list of databases that are used for time series data. There are some that are time series specific, like OpenTSDB, Graphite, React. There's actually a huge list of them on a website called DB Engines. And DB Engines actually tracks all databases, all types of databases, and they have a time series database category. So you're welcome to look at that. You can see that the list is much longer than what I have on this page. And then there are also a number of databases that we see when we're talking to a lot of our users that are utilizing. We see a lot of people that actually start out with MySQL, because that's usually just something that's sitting around, easy to use. And then typically, if the workload gets too much, then they start to elevate into other products like a Cassandra, MongoDB, etc. And some of initially I think a lot of users feel that that's sufficient. But then over time, they start to realize that there's quite a bit of work that they have to do to just keep up with those basic functionalities that you'll find in a time series database. So they have to build all those features we talked about in the Cassandra or Mongo. And that's why often engineers then look to see if there's a purpose-built time series database that's available, and then they'll start using some of these solutions you see on the right. So the primary use cases that we see are going to be in 3 areas. So we see a lot of IoT implementations using a time series database. And if you think about what they are trying to accomplish with this data, it makes sense, right? In the industrial setting, you have factories that are trying to make sure that they have all their machines working optimally, and they want to take measurements over a time interval. They want to understand if that oil pump is continuing to work at the specified levels. There are a bunch of consumer products that are out there. A lot of us wear these devices on our wrists to track our steps or our any kind of health metric, to just then see if we need to step it up a little bit. And all that information is over time. But typically on this side, these are going to be, they are typically using a time series database underneath the applications that they're building, and then pulling that data to then either let their individual consumers know that, hey, there's something's changed and you should make adjustments, or in the IoT case, it may be helping to kick off maybe an automated task, or kick off a warning, or kick off an alert to let individual operator know that, hey, everything's good, or maybe we should start looking at maybe the oil levels in a particular machine. Under what we're calling the DevOps category, so this is going to be monitoring of your infrastructure, your applications, your containers, anything that you just want to make sure is working really well. And a number of use cases here where individuals at various companies may be monitoring this stuff with the use of time series databases. But there's actually also a number of monitoring solutions, especially SaaS monitoring solutions, that actually use a time series database underneath their solution. There's also a number of security SaaS solutions as well. And if you think about what security applications are doing, is they're helping you to monitor an incident or some kind of activity that could be malicious or could be dangerous, and they're measuring it over time to help them know if there is something happening that could be worth taking note over. And then finally, the third use case that we see a lot is when in the realm of real-time analytics. So this could be things like high-frequency trading, where you have these trades that are happening at a second interval, and you want to be able to track the number of trades for a particular item. A lot of times it's going to be stocks, and you're going to want to understand things like the price, the volume, etc. And then turning around and taking that data and then maybe changing the trading activity based on that kind of data. So these are the three typical use cases that we see with time series databases. So at InfluxData, what we have focused on is making sure that we can actually build out a platform that can help you, the developer, to be able to collect all this information and then start working on instrumenting your apps or your devices. Once you have that instrumentation in place, excuse me, then being able to take a look at what's happening and start to make make some observations that's going to lead to certain kinds of activities, right? So once I start taking a look at a particular metric, if I'm looking at temperature readings and I'm noticing that things get really hot at a particular time, then I'm going to start to make some assumptions about some of the activities. I'm going to then probably even see if I can quantify that a little bit further. And once I understand that, and I've learned from that, then I can put in some kind of thresholds. I can put in some kind of automation that's going to hopefully, change things so that we don't put ourselves in harm's way. And you can do that with a number of metrics, and I see this across the board. So on the left-hand side, the IoT sensors and events that we talked about already, that I think just is, makes a lot of sense, right? We want to make sure that those machines are working well, and there's a number of different types of bits of information that we want to collect about that. On the infrastructure side, it's not just about servers and containers, it's about also the things that are in containers, and it can be all levels of your application or your services stack, right? You can look at data about just a small piece of code that you're writing. Maybe you just want to make sure if you're writing something that is in the development phase, and maybe before you hand it off to QA or put it into prod, you want to be able to track the performance of that code that you just wrote to make sure that you're not the one that's going to be contributing negatively to the overall performance of the application, right? How many times have we written something, thrown it into prod, and then the ops team is screaming at us because something is slowing everything down. But this can be a great way to be able to make sure that you're not the cause with the code that you're writing. Business metrics are also something that we see a lot of people using our stack for. And some of these can be things like trying to understand how the users are interacting with your application. So if you're a bank, this could be understanding how many transactions per minute are going through the system. Or even a gaming platform, how many plays or how many activities that people have within that game. So these are all the kind of metrics that are going to help you to understand if there's an increase or decrease of these activities. It could be because there's something wrong with the infrastructure. And oftentimes we actually hear that this actually is a good leading cause of, it's a good leading indicator of something that is happening in your infrastructure. And then finally, we are continuing to extend beyond just like the normal metrics. Recently, we created a Telegraph syslog plugin. So we're actually starting to bring in information from logs. And also, we actually have a number of customers that are also starting to look at traces. But the distinction between us and any of the log management solutions out there is that we're not about collecting logs just to be a log repository. It's really about helping you be able to identify a specified time interval where something might have gone wrong or some kind of change happened. And then from there, you start to look at the logs, you start to look at the traces. And that's important to understand because if you come about it the other way around, it could take you a long time to actually weed through all those items and then determine, is there some kind of a change and is it that warrants really taking a look at those things. So under instrumentation, it's about quickly being able to grab a lot of that data and storing that effectively so you don't take up all your storage. In observation, it's really taking a look at that in real time, trying to make some understandings of what's happening, and then trying to determine, okay, what can we do to control those things? What have we learned from that? And then in the learning, once you have an understanding of what that data is telling you, then you start to thinking about, is this going to happen in the future? Are there some predictions I can put in? And also, is there some kind of automation finally that I can do to help me sleep at night so I don't have to get woken up by these alerts that could potentially get pumped out of a system. So what we have at InfluxData is we have a set of 4 really awesome open source projects. And at the heart of it is a time series database called InfluxDB. And you can use Telegraph, which is our collector agent, to be able to put data into InfluxDB. You can also use our client libraries to be able to put that data in there if you prefer to go down more of an agentless process. You can also, we also do have a service discovery option, and that's often useful in things like containers that are ephemeral in nature. Chronograph basically is just the UI for the database, so this allows you to take a look at what you're collecting, and then you can make a determination, hey, I want to collect more stuff, or maybe I want to tag more things. And it has some really simple dashboarding capabilities as well. But you can also use other dashboards like Grafana, and probably the most popular types of dashboards that our users use are ones that they've actually created themselves. So it could be a dashboard in a smartphone app or whatever application that they're building. And the data that they're collecting is often, might be very specific to certain users. So it makes sense that there are so many custom dashboards that are being built on top of InfluxDB. And then our 4th project is called Capacitor. And this is basically if you want to do some kind of manipulation of the data later on. Maybe you want to train it with some machine learning. And then oftentimes users will actually bring that data back into InfluxDB to be able to provide further insights to the data and potentially what the data is telling us. So this is just a architecture diagram to just show you how these things kind of interact. So on the left-hand side, those are the various bits of time series data that you could pull in from systems and apps, message queues, etc. You can use Telegraph if you want to. Don't have to. As I mentioned, you can use the client libraries to write directly into InfluxDB. InfluxDB can be queried by chronograph or any of your custom apps so that it can then surface the data that was collected. And then you can also use Capacitor if you want to do the service discovery to pull data into InfluxDB, or if you want to take the data from InfluxDB and throw it into some other mechanism to then manipulate that data further. And then you also can do things like set thresholds on that data so that you can throw it into one of the many popular alerting frameworks that are out there. So a PagerDuty, a VictorOps, an Alerta, etc., to then allow your teams to be able to be warned that something's happening and to take some action. And the reason that I'm going over these things once again is I want to make it clear that you don't have to use all four of these things. You can just use InfluxDB if that's all you want. We actually, I just did a webinar with Swiss Re, and they have gone completely clientless, so that all they use is InfluxDB, and they use Grafana for the dashboards. Or you can use all four of them if you want to. It's just completely up to you. You can also actually use Telegraph with a different time series database, and we actually have a couple of examples of that as well. It supports graphite format. Also, Azure Monitor just recently decided to use Telegraph, and so they collect the various what they call custom metrics from applications and pump that into their database. So why choose InfluxDB? Well, of course we think it's awesome, but it's awesome because it's easy to get started. I know everyone says that, but Paul, who's our founder, Paul Dix, who's our founder, is very passionate about this, and he actually coined the term time to awesome. And he feels that, you guys as developers have so many things to worry about. And the last thing that you want to have to do is spend all day long trying to figure out how to install a new piece of technology to help instrument your code. And so getting started with InfluxDB, actually all four projects, is very simple. It just takes a couple of minutes. We also made it so that the syntax is similar to what you're already using. So if you look at the query language, it looks very close to SQL. There's no external dependencies. We already talked about regular time series, and it does allow for that. It's horizontally scalable, and you can use just one of the components, or you can use all four of them in a platform. All right, so we're going to talk a little bit about the InfluxDB model, and the way that I introduce this is that I just use something that we're all familiar with, and that's stock price over time. So this is a typical chart that you'll see. We have three different stocks. We have, I think A is AT&T, I don't remember what double A is, and then we have Apple. And we can see the stock price on the left and how it's going up and down over time. So the label of this graph, in this case it's stock price, we call that the measurement. And so this is the terms that we use when we're talking about the InfluxDB model. The legend, or the data that's indicating the three different stocks in this case, is something that we call tags. And it's pretty useful, and we'll show you some examples of what you could do with tags. And then the collection of tags we call a tag set, so that sounds pretty easy. And as I'm going through this, you'll be like, Chris, this is so obvious. I just want to make sure that we really get this in your head, because these are the terms that we use in our documentation, and it can just get a little bit confusing if you're not familiar with it. So then the actual values that we're collecting, in this particular case, we're collecting price. Those we actually store in something that we call fields. And fields can handle values that are floats, int, strings, or bools. And of course, the collection of fields we call a field set. It doesn't have to be just one, there could be many, and I'll show you a couple examples where you'll be like, oh yeah, that makes sense. And of course, in this particular case, the x-axis is the timestamp. And we can go all the way down to the nanosecond precision level if necessary. So what does this actually look like? So points in InfluxDB, if you look at the very bottom, that's what we call a line protocol, stock underscore price, comma, ticker equals A, comma, market equals NASDAQ space, price equals 177 and 3 cents, and then we have a space and then our timestamp. So that's what we actually need to insert into the database so we can store that information. So let's just walk through that example in a little more detail. So the measurement in this particular case is stock underscore price. The tag set, and we have actually 2 tags in this particular example. The first one is the ticker, and then the second one is the market. We want to know which stock market this value is associated with. And then, of course, we have a price. In this case, we only have 1 field. And then the very last thing is our timestamp that we're adding. So we're adding these 4 things into InfluxDB. Now, we don't have to add the timestamp. If there is no timestamp, then we'll automatically insert a timestamp based on the time that you've inserted that data. But you want to be careful with that because your measurement might have been taken, a few seconds earlier than that. So we do recommend that you pull that data either with Telegraph or whatever means that you're going to use, and make sure that you use the values of the time that the data was actually collected and not the time that it was inserted. Maybe there are instances where it doesn't matter, but there could be, and it could also lead to the wrong kind of conclusion if you don't have that precise time. All right, so once again, we have in this case, we have CPU load as our measurement, and then our tag set in this particular case is the host name and the location. We have it set to server 2 and US West. You can see in this example, we're actually collecting 2 different values. So we're collecting temperature and volts, and then we have our timestamp at the end. So the measurement and the tag set are basically the series as a whole. And then when we look at it with a very specific timestamp, we call that a single point. So once again, these are just terms that we use quite a bit in our documentation. And so at first, it might be a little confusing. So I just want to make sure we spent a little bit of time on that. And here's a couple of other examples of points that are written into line protocol. So the first one we kind of talked about. The second one, you can see in this particular instance, we have different kinds of tags. We have zip code and country. And then we have 2 different values. And notice there's no timestamp on this second example. And then we have another one that's probably just grabbing maybe data from your web application. What's the response time? What's the method that we are actually grabbing that value from? So we can see if we need to make some changes. Okay, here's where it gets super fun. At least I think it does. So I'm going to review, first of all, I'm going to see if there's questions. And then what I will be reviewing this next section are a couple of use cases, and we'll go over some architectural diagrams so that you can get some inspiration about what you can use InfluxDB for. The cool thing is you can do anything with it. The hard part is sometimes you don't even know what to do except for maybe some of the obvious. But some of our users have come up with super clever things that they've done. And more often than not, our users have done things not just for one particular use case, but once they start using it, they start to realize, oh, we can actually use this for a bunch of other things. So it's not just limited to their single application. Okay, so Sean Wong asks, I'm trying to backfill data into InfluxDB using older timestamps. Is there any date restriction? For example, I cannot insert data older than an hour. No, not that I know of. But maybe, Sean, you and I can talk a little bit more what you're seeing if you're actually trying to do this and something wasn't working for you. Next question I have from Angela is, if I want to record the units of a value, should I use tags? It's up to you, Angela. And I think that the tagging can be really useful. And that's why I want to go over some of these use cases. And the reason that it can be useful is it can help you to get just another view of that data. And so for an example, I actually won't go over this example, but one of the examples that I thought was pretty cool is that one of our users has a secure email service that they offer, and they were having problems with latency. And they couldn't figure out where this issue was coming from. And so what they did was they actually started to tag their data. So, and they tagged it in 4 different forms. They tagged it from, I think it was host name, data center, customer, and I think location was the fourth thing. And so when they actually started to look at the data separately based on those 4 different tags, they saw that the latency wasn't caused by the data center, or by the location or host name. It turned out it was actually only one very specific customer that was having this issue. So they were then able to dig into that a lot more, much more efficiently, and identify what the issue was with that particular customer. So these tags are really useful. Now, the one thing that we have to be careful with is you can get a little bit too excited with tags and think that, oh, I need to tag everything. If I'm collecting, let's say, back to that latency measurement, you could just think of every single thing in that environment that you might want to apply to that measurement. But you have to just take a step back and ask yourself, do I really need all that information? Because just collecting everything doesn't necessarily mean it's actually going to be useful. Plus, you will run into a cardinality issue if you're collecting millions of tags for a particular measurement. But, you can collect. There are probably a lot of useful information that you want to collect. And I do think you should take advantage of it because I find it to be pretty useful. Okay, so Bbox is this really cool company based in the UK. And what they do is they offer energy to people living in rural parts of Africa. And in those locations, there isn't an energy grid that's easily accessible to them. But you know what? They want to be able to use lights. They want to use television, tea kettles, or water kettles, and phones, etc. But a lot of times these people can't afford to install a solar panel themselves, maybe for financial reasons, or also there might be. I wouldn't know how to install a solar panel, so there's probably also that as well. But they also recognize that, hey, instead of just like selling these people a solar panel, let's actually offer them a service just like how we get our energy service and pay just a monthly bill. And so what they sell to these users is basically a monthly energy service. And what they actually ship to these individuals is they send a solar panel with a battery so that the battery can store the energy that's being generated by the solar panel. And then these users can use that energy generated to light up their homes. So really cool service that they are able to offer to these users. So what they do is each of the units that they ship out, they actually have a number of different sensors that are on there to allow them to understand how well the combined solution is working. So they need to collect information about the solar panel itself, the direction that it's facing. Also, they collect information about the batteries. How much energy is the battery able to collect? Because as we've all know from experience using our phones, that batteries unfortunately degrade over time. So they want to also be able to track to see, okay, is this something that is going to need replacement? And that's really important to them from a business perspective because they want to be able to send a replacement to their users before it becomes a problem, since their users are paying basically a pay for what you use service. So they have, and they're in locations where it might not have, 3G, 4G connectivity, so they do have to rely on GSM. So which means it's a really tiny pipe to be able to, use to send that information. And in the event, they collect all the values from the units. They actually send it to their instance of AWS, and then from there, they found it was easier for them to then pump that raw data into InfluxDB and then be able to store it. And then they actually throw it into a machine learning system that they've actually built to help them to then generate the appropriate alerts as well as do some predictions. And they've had some really cool surprises with the data that they've collected. So one instance is that they were starting to get a number of complaints from their users saying that the battery wasn't pulling in enough information or pulling in enough energy for the users to use this. And so the nice thing is they were then able to really look at the data from the various devices to try to understand what was actually happening. Is there some kind of a fault with the battery, with the storage unit? And what happened was they actually found a pattern that they hadn't considered early on. And they had just thought that people would use the batteries during kind of normal waking hours, right? In the evenings when people are watching television or cooking, and then they would shut it down when they went to bed. But living in a really rural areas, a lot of their users actually use this all night long because they wanted to make sure that they could have the lights on outside because it's really dark, and it was more of a security and safety concern. And so as they started to see those patterns, they realized, let's make a change to our pricing. And let's make sure that we can also have a battery that can accommodate that particular use case. And here's just a real quick look at one of the measurements that they actually collect from their solution. And you can see here, they have, in their particular case, they are actually collecting 3 different measurements. They're collecting voltage, current, and temperature. And they've tagged that data into product ID, because they have a number of different products. Over time, you might upgrade certain products. And so you want to make sure that you understand what's actually out in the field. And also they want to make sure they understand what is the type of battery that's being used with the generation of that particular measurement. You can see here, there's 2 battery types there, worried about a lithium battery and a lead acid type of battery. So hopefully this will serve as some inspiration for you when you're thinking about what kind of tags you want to apply on your data. All right, so a different use case is with a company called Wayfair, and you may or may not be familiar with them. In the US, they're quite prominent on television, etc. And they basically sell furniture. And what's really cool about them is that they actually have very technical beginnings. And I recommend taking a look at their blog. Their 2 founders were actually engineers that realized that the problem that they wanted to solve is that there's lots of different furniture manufacturers that are that could use basically an aggregator to be able to sell, pillows and couches and beds all under a single retailer. And so that's how they built out Wayfair. So underneath, they have lots and lots of systems that they have to tie together. And for them, of course, how the business metrics are really important, because that's going to really have an impact on their top and bottom line. So how long a user is sitting on a page, how long a page is loading, and they have to look at this across the board, because people don't just shop on a desktop. They shop on their phones, on their tablets, etc. So there's a lot of things that they have to track for. And they also have some key dates during the year that they also have to really make sure that things are going to be working really well. So in particular, this was a surprise to me, but the Cyber 5 holiday weekend, which is actually coming up, is a really important date for them, because apparently a lot of us consumers make sure that we go and buy a lot of furniture in preparation for the holidays, so that when our relatives come, they can be comfortable. And so during this time, they don't want to stop making any changes to the infrastructure, but they definitely want to make sure that as they are deploying code, that they can make sure that they understand the potential impact of the performance of that code, so that they can react quickly if things are worse. And if things are better, that's wonderful. So you can see here, they're collecting data from a number of different data centers, from a number of different apps, and then on the client side, they have over 20 million measurements that they're collecting across lots of different pages. And they have to make sure these things are functioning, because their marketing teams have a lot of campaigns that are in place trying to push, various units, and they want to make sure that those campaigns are effective and not impacted by any kind of a performance. So they were a big graphite shop before, and they loved graphite, and but they wanted to work with a partner like InfluxData to really focus on things like, ensuring that there's HA in the database side, because they were having to build that in graphite. So they made the switch. They've been making the switch to InfluxDB. They're not 100% there yet, since they do have to put everything, kind of slow things down during their busy November timeframe. So here's a look at their architecture. And so what they appreciated, and I'll be posting this, so I won't go into all the details here, but what they really appreciated is the flexibility of the TIC stack. So they have 3 different data centers: Ireland, Boston, and Seattle. And at the very edge, they wanted to make sure that they could grab all the metrics from their apps really quickly. So they just wanted to use UDP in that instance and throw that and grab that with Telegraph, and then throw that into Kafka, so that they can then bring all that data to their central data center in Boston. But then going from Kafka to InfluxDB, they wanted to then use TCP. And they appreciated that they could do that. And they also appreciate that if they want to flip that around or change that, it's not a big deal. It's really simple for them to be able to do that. And it also really helps them to support their if there is any kind of a connectivity issue. So they could make sure that they could mirror any of those metrics if needed. Just a couple of limitations that they were suffering from with graphite. In order to have HA be a reality with graphite, they had to actually do a lot of work, and they just felt that they had just way too much other stuff to deal with. I mean, 20 million metrics a day, that's understandable. They must be building a lot of functionality in the Wayfair properties. They also actually appreciated that InfluxDB had a wide range of use cases, and Jim and Jordan from Wayfair bring this up quite a bit. Even though they're not an IoT use case or they're not a real-time analytics use case, they love hearing about those different use cases, because they recognize that people may use this tech in different ways that might be interesting for them to implement as well. So they really appreciate the active community and the diversity of the use cases, because they feel that that's going to help them to explore other ways that they could also use InfluxDB. And then Jefferson, you have a question. Let me just look at that. It says, does Telegraph have a support for OPC UA? Yes and no. So we have a set of Telegraph plugins that are already available. There's over 160 of them. Those are the ones that the community members brought back into the fold. There are actually a number of plugins that are actually that have been forked that people have been using for their own. In fact, I'm going to skip over Playtech, and we'll actually talk about an OPC UA collector agent with this use case. Because not only have these guys built a OPC UA collector agent, they are in the process of building a server so that you can actually bring information back into the factory. So ANS Energy is a biomass plant in Belgium, and basically what they do is they burn non-recyclable wood to be able to generate steam, which then generates energy. And they were actually using a traditional industrial historian for their solution. And so the OPC UA was really important to them. They have their SCADA systems that are pulling telemetrics from the various sensors and the various components within this biomass factory. So they have to check for things like water pressure, steam, also like oil, because they have tanks that are storing oil for the various components, etc. And so Oops, the title's wrong there. So, one of the problems that they actually had is that they've been using their solution for quite a bit, but they thought, or they had this hunch that they probably weren't being as efficient in the use of this solution. And as they started to just, look around at their staff members, they started to realize, they have this big industrial historian solution, which is supposed to help them, and the SCADA systems, which is supposed to help them collect all these measurements and allow them to then, do predictions on it. But they found out that there were so many other things that they were using. So they were using paper. They were still using a ton of paper. A lot of the operators were walking around the plant and collecting measurements and just putting them on paper. And then that information sometimes was brought back into the overall system, or sometimes it was just chucked. They were also using a ton of Excel reporting. And, I think Excel is good for just kind of like real quick analysis, but as we know, if you really want to build a dashboard, you can't use something like Excel. And they really needed to have something that could be a lot more accessible to their staff, as well as allow them to, pique their curiosity and be able to look at data in more ways than one. The other thing that they were having problems with their data historian solution is that it was only allowing them to have 2 weeks worth of data for their historical views. And they needed much more than that, right? Because they need to know, is this working as expected compared to a year ago, or compared to last season, or whatever it is. So 2 weeks of data was just too painful. And when they did want to look at something that had data from more than 2 weeks ago, they actually had to go to the closet where they had these solutions, because they aren't using the cloud, and they had to bring a hard drive with them to then grab more data, and they can only grab 3 months worth of data at a time to be able to do any kind of predictions based on historical information. So the overall factory data historian solution is what they were able to use to replace their previous solution. And the factory data historian has InfluxDB as the storage for the time series data. They also have an OPC UA connector, and they actually use Grafana. Remember, I said you can use whatever dashboard you like for the visualization layer. And so some of you might be developing solutions for your various customers and prospects, and so you can see that InfluxDB is really going to be a great solution to kind of put behind the scenes on the solution that you're building. So just a quick look at their architecture. So they actually have data coming from lots and lots of sensors. So sensors that are created by Siemens, Rockwell, Schneider. They may or may not be compatible, but these things do use OPC UA, the OPC UA collector that they put together. And you could definitely find information about that on their website, or you can just shoot them a line, Jefferson. The guys there are very responsive. All the data is stored into InfluxDB, at least the time series data is stored in that. And they actually also have information in a Postgres database, as well as they have some other ERP databases. And what they have in that is some information that's going to give them a little bit more context, right? So information like what the factory machines are, when were they installed, when was it last updated or modified, who actually did that, what are the parts that are a part of it, right? A lot of that contextual data that's really required to help understand, is it time to make it a replacement, or is everything just going really well? And then they have their Grafana dashboards, so that management no longer had to use paper reports or Excel sheets. They could actually start to just directly interface with that and really be able to take a look at much further back historical data to make sense of what was going on in their implementation of their power plant. The other thing that was cool is that they also for the first time gave their operators access to this Grafana dashboard. And they hadn't done that before. They just kind of, would tell them, send alerts and tell them, oh, go fix this or go do that. But what was interesting is their having access to that data really allowed their operators to kind of think about situations that management hadn't thought about. And they were actually able to find a leak in one of the tanks that actually saved them over $500,000. And it was just simply, you know, giving access to data to the right people. So you can see here, you know, why they've replaced their existing data historian. And I think I've talked about all these points. The one thing that was kind of surprising is they actually still had Windows 2000 in their environment. And that was actually making them very nervous because it was working, and they were worried if they took it away, would things just completely break down. So other things that they appreciated, they also do appreciate that you can have various retention policies set, so you don't have to have, you know, one retention policy for everything, because there's just some data that they just want to keep forever, and then some of it that they are more than happy to start to extract. They also appreciated the platform independence, especially with their fear of still having Windows 2000 in their environment. So we're at top of the hour, and I see there might be one more question. And so the question from Retta, is there any built-in connectors for BI tools like Tableau? Not that I know of, but I'm sure we could probably ask the community to see if they can build that. But, you know, I would take a look at Grafana. Grafana is a great tool. And, you know, if these operators can use it, I'm sure your customers and users can use it as well. So I'm going to actually go over one more use case, but I understand because it is 9 o'clock and this is an hour-long session. So if you need to head off, please do. I will make sure that as I mentioned earlier, I will clean up the recording before I post it, but this will be up there, and we'll definitely keep it for this next use case, which I think you might find interesting. Okay, so let's go back to my deck. We'll just go over one more use case. And there are plenty. I have a bunch of these use cases in a webinar form on our website. So you can take a listen to these users directly. And one of the things that I make sure that we do in these webinars is that it's not all about, oh, isn't InfluxDB just super great and it saved $10 million by implementing it. It's really about sharing the experiences of using our stack. So you'll notice that these are going to be engineers like yourself reviewing their data architecture and also reviewing what didn't go right. I really want to make sure that this is as authentic as possible for everybody so that you can see that, this is important, that we share this information. So Playtech is actually a giant player, and they have built a gambling gaming solution or platform so that if you wanted to build your own poker game, you could do that on top of their platform. So for them, it's really important that they can keep their solution up and running, because if you are building a game on top of their platform, well, your source of revenue is making sure that people continue to play and they continue to, you know, pay for playing that service. The tricky part for them is that not only are they this worldwide site, but at each location around the world, there's also a lot of different financial regulations that are impacting their system. So how they implement maybe, you know, a credit card solution in London might be very different than how they do it in China or US or Japan. So they have so many variations in their back end that they have to be careful just assuming that certain characteristics are an indicator of something that's going bad or not. And it was actually kind of a cultural thing that they had to really contend with, that you know, maybe you may not really understand what's actually happening with your solution as you think you do. And it wasn't that they were trying to you know, beat up on anybody. It's just that with all these variations on their back end, they really had to kind of take a couple steps back and say, hey, maybe I don't really understand how these systems actually work. And maybe we need to start to put in place a mechanism so that we can start to observe the differences, and then based on that information, you know, back to what we were talking about early on, collect information, instrument, learn, And then from those learnings, then determine, okay, these are really obvious KPIs that we need to take a look at to understand that things are going well or not. So they have 2 levels of system monitoring in place to help them with that observability. So your typical low-level monitoring, which they actually found sometimes doesn't actually reflect a real issue. They actually find that the high-level monitoring, these are things like the business metrics actually are much quicker to point that there's something wrong. So one example that Alex gives in the webinar is that they were basically had all this alerting around the logging, the login infrastructure, making sure that people could log into the gaming platform and the games that were on top of it. But what turned out is that most of the users that are on these games are actually logged on for long periods of time. And so they may not have a problem with logging in because they're still logged in from a previous session. But what they did notice is that when they would see fewer transactions, then that actually was a better indicator to them that the system that helps these users log in was actually a problem. And he goes into really quite a lot of detail on that, and I definitely would take a listen to that. We've also have a written form of that case study on the website as well. And in fact, we do for all of these things. The other thing that they're starting to do is now that they have this kind of monitoring in place, they're starting to look at other types of data, other types of contextual data, similar to the ANS case, that may also help them to get to resolution faster. For example, understanding who is responsible for the various product portfolios, who the product line owners, who are the product owners of maybe like very specialized features, who are the engineers that are responsible for them, et cetera, so that when they do find those issues that they can actually let those individuals know very quickly so that they can address them in a much more organized fashion. So really trying to make sure that they can understand what's going on and who can help them to address it. So they went to a microservices infrastructure, and they really had to because their solution is so complex and so varied. You can see here what they are doing is they're actually putting their time series data from every metric, every event that they are tracking into InfluxDB. And then applying a bunch of rules on that data so that they can figure out, is it a problem? Is it not a problem? Who then should get messaged? What should we do about it? And then constantly kind of take a look at the rules that are in place to see if they're still applicable. The other thing that they appreciated about InfluxDB is that all their microservices are actually executed on their own Python VMs, and they just felt that the flexibility of the solution just helped with that. They were actually using a product from HP to help them with understanding if there were any kind of anomalies. And one of the problems that they had is that every time they ran into problems with it, just the turnaround time was just too slow. And so they just decided that they needed to build something themselves that they could basically manage their own destiny, so to speak. So the solution that they had, not only did it yield a lot of false positives, but also a lot of false negatives. And the granularity was just too large, 15-minute increments. It just wouldn't allow them to be able to address anything. And of course, they got the dreaded tweets from the users about how things were just not performing. If you talk to Alex, he's very passionate. He talks at a lot of different meetups and a lot of different events. He is more than happy to share a lot of his experiences, and you can reach out to him directly or be more than happy to get you in contact with him. And then we go back to the ANS Energy. So those are just a couple of use cases. We have plenty more. I would recommend going to any of my webinars on Tuesdays. We definitely go into a lot of these. Last Tuesday, I actually did a webinar with Capital One, and we reviewed how they actually put in how they implemented InfluxDB with their disaster recovery projects. So that was pretty cool. And if you have, as I mentioned at the start, if you have any cool use cases that you want to share, just reach out to me. Be more than happy to listen to what you're doing with the TIC stack, and maybe we can, then share that with the rest of the community. So it looks like I don't have any questions. I'll leave the lines open for just a few more minutes if you have any questions. We can definitely chat more about the various use cases, but hopefully this gave you an understanding of why you should consider using a time series database for the collection of these very precious metrics that you probably need for your applications and your services. And I recommend just trying it. I didn't really get a chance to go into how to install and how to actually start to insert data into InfluxDB, but there's plenty of documentation online for you to get started, and hopefully we'll see some cool stuff from you guys. Okay, awesome. So if there are any other questions, just put them in the chat in the Q&A. I've already answered a couple of them that have, and I'll just read them out loud. So we had Toter asked if InfluxDB could consolidate old time series data. And I'm guessing that you're asking if we can downsample the data, and we definitely can. I put in some links for the documentation to show you how to do that. And there was also another question about altering tags, and you can use the select into query to help with that. And I also put the documentation links in there as well. So I'll just hang out for a few more minutes, and if you have any questions, please feel free. Okay, so these webinars are posted, so you can take another listen. And if you have any questions, you guys have my email, so please feel free to reach out. Thanks, everyone, and have a fun time with the TIC stack. Bye-bye.